Let's get started then. So, welcome everyone. Thank you for joining us here to another RatedPower webinar. Today, the title of our webinar will be Maximizing Energy Yield, a breakdown of pvDesign versus PVsyst. A few things to mention before we start. The webinar will last for about 45 minutes. If you have any questions during the webinar, please feel free to drop them on the question box. We will try to answer all of them at the end of the webinar. I will probably have around 15 minutes to do that. If we get too many questions and we are not able to answer them, do not worry. We'll try to get back to you, or we will get back to you through email after the webinar. In addition to everyone that is here and anyone that has to leave earlier, I will be sending an email to all of those that have registered to our webinar, and we will include the recording for the webinar, as well as some resources that we will be speaking about here today. So let me introduce our host today. We have with us Hassan Farhat. Thank you, Hassan, for joining us. Hassan is lead technical advisor for RatedPower. He has been working for RatedPower for over 4 years, nearly 5 years now, supporting a lot of our customers. And now he's leading a part of our customer success team. So, well, Hassan, thank you for being again here with us. And then, of course, me, Gabriel Cañadas, I'm a senior account executive, mostly related with our customer base in the US market. So, about today's webinar, here is our index for the day. I will start with a brief intro to pvDesign. We'll continue speaking a little bit more in detail about our energy model. Then we will dive into the comparison that between PVsyst and pvDesign, so how our users can do an accurate comparison of these two models. And then we will dive into the Black & Veatch independent review that carried out comparing our energy model to PVsyst. And as I mentioned earlier, we will leave at the end around 15 minutes to be able to answer any questions that we get. Remember, you can ask any questions through the question box. So first, about pvDesign. So who we are, what is pvDesign? pvDesign is RatedPower's solar anywhere solar design and engineering software. Some of you may already know RatedPower got acquired by Enverus about a year ago. So now we are part of Enverus, supporting our customers in all the phases, development phases of an energy asset. But focusing on pvDesign, pvDesign is a cloud-based software. So this means you can access it through your browser. As long as you have internet connection, you will be able to access it. This means that we believe pvDesign to be a collaborative tool, meaning that many different users can access the tool at the same time. They can work on each other's projects, check each other's projects, as long as they have internet connection again. So it doesn't matter where you are in the world. If a company has many different offices around the world, they could all work together and collaborate within the software. It is a one-stop solution. By this, I mean that we are not only focused on the PV design, so the PV array design and engineering, but we also support the engineering of the substation tied to that PV project, of storage project as well, coupled to your PV asset. And then we do also support the basic engineering of the overhead line or gen-tie line, transmission line connecting your project substation to the point of interconnection. pvDesign allows our users to rapidly iterate and create different simulations, trying different equipment, electrical, civil configuration to find the best path to move that project forward and to optimize that asset. We also have a cost estimation tool that would allow to identify very early on the design phase what costs are related to your project. So having a total cost breakdown of capex breakdown of your project. Then the software, for every iteration that our users create or generate, it will generate as well a package of engineering documentation that will include layout, single line diagrams, bill of materials, and many more documents. We will be able to see some of them later. and of course, we will provide energy yield results for that specific design, as we have an energy model running behind, which is what we will be speaking about today. So without further ado, Hassan, I leave the floor to you so you can speak a little bit further about our energy model. Thank you.
Perfect. Thank you, Gabby, and hi, everyone. So before I actually delve into our energy model, I think it's also important to mention why it's necessary kind of to have a good energy yield model for your assessment. This will obviously, as we can see, help give a greater precision in forecasting the performance or the efficiency and production of our PV plant for the life cycle of it, that we're saying usually 25 up to 30 years, or sometimes could even be more. Also, it's going to give us a bit more confidence in the viability of the design, so we can make sure that this project makes sense, that the configuration that we have set for the equipment and so on are the correct ones. And of course, if we have precise results, if we can trust these results, we can also make sure that the banks can trust them and will be able to give us the loans that we require for these projects. With that being said, we can now actually start talking a little bit more about our energy yield model, how it works, what algorithms it has, and so on. So first thing here to say is that our energy yield model is an in-house model. So we've developed this internally. It does, of course, have different packages from other tools. For instance, it does use a Solpus software package, which comes from the NREL for calculating the position of the sun. And of course, it follows the typical well-known Pareto diffuse transposition model, as we can see. When it comes to calculating the actual energy, it does a linear shading 2D geometric calculation model, which means that it considers the terrain to be flat. We do usually receive a lot of questions, what about 3D geometry, what about 3D shading, and so on. This is actually something that we are already working on. However, there's no set deadline on when that will be out. When it comes to the backface irradiation, so we're talking about the bifacial modules, something that is nowadays we see more and more PV plants using that, and more projects just being designed with those. We have a view factor backface irradiation model based on the NREL model, and a standard one diode model, which depends on the characteristics of the PAN and OND files to do the modeling of the system. So the PAN and the OND files are the typical files for the modules and the inverters, which are also very well known in the industry as they come from PVsyst. This standard one diode model does have a lot of similarities with the PVsyst model. However, due to the lack of documentation in some aspects from their side, some things will be just a bit different here and there. And finally, when it comes to the MV, or should I say the medium voltage electrical system, we have also our own internal modeling system. With that out of the way, I think now we have a bit of a good idea of how our system works, what's the algorithm all based on. So perhaps we can start with how to actually conduct a good comparison between PVsyst and pvDesign, or at least how to kind of simplify it and make sure we're looking at the right parameters and the right outputs. So to do so, I'm actually going to delve into pvDesign. So I'm going to immediately delve into our design process. So this is the design process of our tool. Here we can see on the left side bar the different tabs or different sections that we can control and modify for the design. So the first thing, and actually the most important, let's say, input that you need to take care of and make sure is exactly the same in both tools, or for that matter in any tool that you are comparing for the energy yield modeling, would be the meteorological data. With this file or this information not being the same, you're basically not comparing this, let's say, apples to apples. You're just doing a comparison that from the starting point is not completely correct. So to do so, inside our tool, we have some options which are free to use. They will depend on the location, like for instance, the PJS5, the NASA Power, and NASA SSE. But also, in case you have subscriptions with Solar Anywhere, Solcast, or SolarJS, you can actually add your keys, and with that, you'll get those data directly for your designs. Otherwise, if you want to use other sources, or maybe you have a CSV file with the information directly from a client of yours or from someone or a study that you've done, you can just upload that file by selecting the right format over here. And even you can use our templates or generic templates to add in the data that you need, and the software will also automatically read that without any problem. You can always, of course, refer to the how-to articles, which are our Node-RECE articles, to know a bit more on how this works as well. Once you have the meteor data ready in both tools, let's say in this case, exact same data, you can move on to the rest of the system. We're talking equipment, electrical part, detailed energy losses, and so on. So if we move to the next one here, the equipment. PV modules and inverters mainly. So to these, for these, of course, make sure you're uploading the same PAN and OND files. It's preferable that you manually upload them, because even though you might see the same name of the coming from the manufacturer, sometimes some characteristics might be slightly different, just because maybe one tool has a less updated file or equipment than the other one. So just to avoid these differences, it's better to upload the PAN and the OND files manually. In our tool, you can actually do so. So we do have a very extensive database that we always update for both equipment, but in case you want to upload your own equipment, what you can do is you can go to the equipment tab. And if I show you the equipment tab, basically over here, you can upload those files I mentioned. So the PAN file for the modules and the OND file for the inverters. And these are basically private databases. So whatever here as a client or a user you upload, only you and users from your company will be able to see and to use within your simulations. Okay, with that out of the way, the next thing here, also regarding these two specific equipment, is of course, you want to make sure you're setting the right plant size in both tools. And the two tools, so PVsyst and pvDesign, they don't exactly work the same way when it comes to this. So for instance, here the design will pvDesign will automatically set the DC capacity for based on the site that you have. So for instance, in this case, I have this big site that we have in California, and the pvDesign just automatically fills it in for me. So how could I know how much or how many modules I have or how many strings I have? Or how can I set that in PVsyst? Because usually PVsyst, for instance, has a parameter for the number of strings. That is actually quite easy. So we can refer to one of the documents that we generate, which is the project sheet. I will talk a bit more about documents later, but for now, I'll just mention this one briefly. So the project sheet actually does have some summary or review of the outputs that the design has. In this case, we're mainly looking at the number of strings. So this value will be the one to input into PVsyst, but also you have the number of inverters, which you will also have to input underneath the inverter in the system section of PVsyst. Sometimes PVsyst might ask you to, or will automatically have the option for the multiple MPPT. Just make sure to uncheck that box, and that way it will allow you to set up the number of inverters instead. With that out of the way, the next thing would be to check the structures. And sorry for moving a lot between the different tabs. So basically for the structures, you have 3 different options: single axis trackers, fixed structures, and east-west structures. Usually in PVsyst, you would go, if I'm trying to name the same namings for each, you would go for unlimited trackers, unlimited shads, and several orientation options within the orientation section. So just make sure you're applying the same option over here, and also make sure that whatever type of structure you have, you're applying the necessary related parameters. For instance, things like the pitch distance, or let's say the tilt angle when it comes to the 2 other types of structures. Also make sure that depending on the type of configuration, so for instance, in this case, we're using a 1 vertical or a 1 portrait tracker, you make sure that you take the dimensions of the module, which you can see in show details, and you apply those to the bandwidth inside the PVsyst, so that you have the right size of trackers or structures over there as well. With that out of the way, the next parameter would be the number of modules per string. Just like PVsyst, we do actually also recommend a certain value and a range of values. However, this range might not always be the same as PVsyst. For that reason, what you can do, and this you can do either way, is either when you go to PVsyst to set up the value that we gave you, for instance, that we recommended, make sure to change the minimum historical temperature over there within the project settings if needed, just so that PVsyst doesn't block you from moving on. Otherwise, what you can do is you go back to our location tab, and over here you can change this minimum historical temperature within pvDesign to make sure that whatever you have set up over here is being read as actually a recommended value and would thus not incur extra losses. Next, of course, you have a few more parameters. However, the one that we would really recommend that you take care of in the case of bifacials would be the minimum ground clearance. So this is just me talking about basically the height of the structures from the ground. This is mainly for bifacials. However, it does slightly affect monofacial modules as well, but given that it's mainly for the other ones, make sure that you set up the right value within PVsyst as well. Finally, to talk about something with regards to pvDesign is that we never stop at the inverter's output. We actually do the design, as Gabby said or mentioned earlier, is that we go all the way towards the point of interconnection. So basically, we are taking into consideration the medium voltage system, the high voltage system, and so on. So for that reason, we do allow you to play with the, let's say, the power station or the transformer station, where you can define the losses of the iron and copper. By default, PVsyst does not have these enabled, so you'd have to manually enable them, and thus you'd have to affix the right values over there. Same thing for MV and for HV as well. So usually, to simplify comparisons, we recommend just to disable this option, as it will not affect the results that much, as they follow same typical algorithms. And that way you will have an easier comparison to follow, and you will focus on the main things like the inverter losses, the transposition, and so on. Next, you may ask about the DC to AC ratio. However, this is something that you don't have to worry about, since you've already set the number of strings correctly and the number of inverters. That is already taken care of in both tools. So this is something that you can skip. And of course, we've already mentioned the pitch distance. So just to show you, it's found in the layout tab under the distances section. With regards to the HV, or let's say the substation transformer losses, they're also found within the losses part of the grid point section. And alongside those, we can also see the power factor, which by default we would say for a comparison it's easier not to mention, but of course you may need that in your reports to make a more detailed comparison. So in that case, just make sure you enable it here, you set where you want to have it, and you set the value for it as well. Finally, within the electrical tab, right before the actual energy losses, we will see some losses related to the cabling. So basically, within PVsyst, you can set what would be the ohmic losses. In our side, we would call them the maximum voltage drop. However, it works in a similar manner. So just make sure you set these values accordingly in both tools. And with that, you'll be basically set to go to the last tab, which would be the energy tab. And here, this one's going to be very straightforward. So simulation is just you setting how much data do you want to get in your reports. Do you want to get information like yearly production for 1 year, or would you like to actually care about 30 years or 50 years even? So almost the full cycle of the PV plant. You have the interannual variability, which will mainly affect the P scenarios, like we're talking P75, P90, P95, and so on. The horizon data that will also be automatically available within the tool. You have QGIS5, or you can just set a flat horizon. Otherwise, in case you have already a CSV file or a .hor file ready, you can upload that equally here in pvDesign as well as in PVsyst to maintain the same parameters, the same data for that file horizon shading calculation. And of course, same thing for albedo. So we have various options. We have different databases, automatic ones, and also we have the typical reference values based on the type of terrain, or if you prefer, you can also just create your own monthly profile, however you prefer. And with that, we're actually now reaching the PV module losses. So these will be very common names found in both tools, and obviously in most tools that do energy yield modeling. So first thing will be the the module degradation. We divide this into first year and into yearly degradation. For simplification, usually it's better to set both of these as 0. The only reason why we want to set them as 0 for a comparison is just because there might be differences in how we apply degradation compared to PVsyst, so the comparison might not be completely correct. However, feel free, of course, to still include this if needed. The module quality and the LID, or light-induced degradation, are very similar values in both tools, so just set the same value. Same thing for the mismatch. However, the only difference here would be that PVsyst will divide mismatch into both module and string mismatch. However, we would just be one value, the module mismatch. So in that case, make sure you add up those two values in PVsyst into one value within our tool. And finally, bifacial mismatch. Given that there isn't much documentation on exactly what they do, what PVsyst does in terms of this parameter, we would recommend that you actually set this to 0 for a comparison, just to make sure everything is on the same side. And finally, the soiling losses. So you have the front face and the back face losses, which you can define as either yearly values or again as monthly, month by month. With the PV module losses out of the way, next would be the auxiliary losses. So we're talking about plant availabilities, also again of the PV plant, but also of the grid, and also auxiliary consumption losses of the inverter, mainly also here the nighttime loss. These values, so mainly the inverter auxiliary losses, they will automatically be extracted from the OND file. So that's the file of the inverter that we talked about previously. If they're not available, they will just be set as 0, like here, the consumption and the consumption threshold. Of course, for a comparison, again, we're trying to simplify things here to focus on the important stuff. So it's better not to include these in a comparison, as they will be adding extra losses that are always the same in both tools. And the final part here of this comparison will be actually some also energy-related parameters, but a bit more advanced, like the constant heat transfer coefficient or the typical U factor. In PVsyst, you may remember a parameter called the or a checkbox actually called the free mounted module free circulation, something like that. That checkbox, make sure to enable it always. By enabling it, it will automatically set the U factor in PVsyst to 29, and that way it will work in a very similar manner as here. Otherwise, just make sure to enable it and then change the value to whatever is needed in both tools, but always check that box. Same thing with the wind loss factor, it's available in both the same way. And finally, the IM loss model. For the front face, you can select whatever model you need here and just apply the same one over there. However, for the back face, make sure you only set the air glass model, as this is what PVsyst has by default. And if I'm not mistaken, it's not something that you can currently change manually over there. For the front face, a small recommendation would be, for a comparison, not necessarily for typical designs, would be to go for Asher model. It's the most conservative, so kind of me saying it will give the worst results, but it's better for a comparison in this case. And finally, the time shift is a parameter that will kind of correct, if necessary, the solar positions by moving a bit the intervals of the data. However, this is something that we will automatically calculate for you, so don't worry about having to modify this value at all. With this being said, we've covered now most of the things related to the comparison, and we've included some of the simplifications that you could do. So perhaps now we can go back to the rest of the presentation.
So Hassan, maybe are you gonna show us well the results from pvDesign?
Yeah, I'll leave that to the end once we do the Black and Veatch part.
For sure.
So next would be the Black and Veatch findings. So this is the comparison that they did. It didn't necessarily include a lot of simplifications. Instead, they made sure to include as many parameters as possible. Of course, anything that I will mention here or not even mention will be in the Black and Veatch report, which is a document that Gabriel will later mention also, that we will send you through email after the webinar, so you can go into more detail about the findings and about the different configurations that they used and so on. So what are these actual cases that they took? So Black and Veatch took 4 different cases, so 4, let's say, different configurations in 3 different locations. These are in Germany, 2 of them in Texas, and 1 in Spain. We can see from the table, the main thing here we're trying, by the way, to differentiate is kind of the latitudes. So we're trying to get different latitudes for the testing, as that does affect the energy yield calculation. We can see here that we took, for the Germany case, they took fixed tilt with monofacial modules, whereas for the rest of the cases or locations, they took single axis trackers and then varying between monofacial and bifacial modules. The findings that they actually reached were what we can see in the following table. Again, all these tables, by the way, they're from the report, so you can, over there, they will delve more into detail on exactly what are the reasons behind these differences, or what are the reasons behind the choices that they made, and exactly what equipment, what parameters, and so on they used as well. So the difference actually did vary between what we can see here also 0.07% and 1.1 almost percent, with an average of 0.42%. Which means that we are quite close to PVsyst in terms of results. However, an interesting thing to mention here is that we are, in all cases, at least in these 4 cases, slightly above PVsyst, not below. So we're giving a slightly higher PR, slightly higher total produced energy throughout the year, and slightly higher specific production as well. With this said, I'm actually now going to go back and mention some of the things that we generate for you to know a bit more about the energy results of your plants. So some basic parameters, but also some documents and really detailed information that you can see. So the first thing here, before I do that, is to show you where you can actually check that. So within our project, if I go to any design, we can see here the results of that design. On the upper tab, we can see some really simple parameters like the capacities, of course, DC to AC ratio, but for this case, the energy, annual energy, the specific production, and the PR. And of course, what Gabby mentioned, since we do a cost estimation, you can also see over here the total price or the capex, the specific price, and the LCOE. However, the documentation that we're interested in is what we can see in this list over here. As you can see, it does come in different languages. It also comes in different formats. So you have both PDF, but also editable formats. We're talking here Words, Excels, CAT files, KMLs, and so on. These will include a lot of different reports, bill of quantities, different Excel sheets for cabling, for the piles, for topography data, financial analysis, and so on. And also in terms of drawings, of course, we have the layout, both 2D, 3D. We have even a PVC file or a PV Colada file, which is a 3D shading scene, which you can upload directly from our tool to PVsyst in case you want to check the layout or do 3D analysis of it there. And we have different SLDs of the different parts of the system. So again, this is not only limited to the PV plant, but also does include other aspects like the batteries, like the substation, and overhead lines as well. The document that I will talk a bit about, or I will show you today, will be mostly the energy yield reports. So this one over here, the energy yield results, and what I've already mentioned was the one earlier was the one called the project sheet, which has a bit of a summary, let's say, of the different aspects of the configuration. But before I move on to that, just going to show you that you do also have a bit of a summary of your system in the configuration tab. So things like the equipment, like the electrical part, and also some civil aspects. And you do have a quick summary of the first year energy results, so the different losses and gains of the first year in the energy tab. So these names perhaps here might sound a little bit familiar because they are very similar to those losses you will see, of course, in the loss diagram you have in the PVsyst report. Same losses, sometimes some things or the reporting of some things will not be exactly the same. So for instance, for the back face losses, we do actually have report different losses from what PVsyst does. However, of course, we still give you how much gain you got from the back face or from the use of bifacial models, just like they do. So that would be the bifacial gain. However, you will not be able to basically compare the same parameters here and over there. Only a few of them, yes, but the majority of them, which are bifacial specific, not really, as they're a bit different. And of course, you have the rest of the electrical system. However, let's actually delve more into these within the reports. So first thing is the energy yield report. You can see here, usually it would have the logo of your company, and it will be kind of personalized towards your needs. And here we can see a bit of a table of contents. Hopefully you can see good enough. We have a bit of an introduction, and then we delve into information about the location, how much areas you have, topography, and horizon. This is mainly because we are not only an energy yield tool, we do, of course, as well layout, civil aspects, cable calculation, a lot of more stuff than just energy. So we have also to mention all of that information over here. Again, the solar resource, the most important input for this comparison would be this part over here, alongside the horizon profile, a description of the different equipment. So we're talking, for instance, let's say PV modules. So what are the characteristics of these modules, for instance? What are the dimensions? What are the voltages, the currents, the power? Same thing for the inverter, the structures, and so on. After that, there's a section about the different losses. So sorry again for moving too much. That would be section 6. Here we can have the different losses with an explanation of what each loss means and the percentage value of that loss. But finally, the actual interesting part that we almost or kind of looked at in the energy tab earlier would be the energy yield results. We start with a small summary table of the production of the first year, the bifacial gain as well here, like we have 5%, the PR, and then we move towards brief down of all those losses with the exact value plus the percentages, starting from the very first point transposition on the plane of array of those modules, including the front face, the back face, and then moving towards the rest of the electrical system, all the way towards the interconnection point. We can see here the outputs or the energy at different points of the system. So inverter input, output, the MV system output, substations output, and then the grid itself. And as you can see, we do have the power factors mentioned. In this case, we did not use a power factor for this simulation. However, it will always show you the actual power factor at any given point in case that was enabled, and how much reactive power you even have on those at those different points. After that, you have some nighttime losses, some transformer losses as well in a summary table. And finally, just a bit of a summary table for the different tiers for the energy yield, the specific production of the PR, or performance ratio, I should say, which will be the number of years that you have set in that simulation parameter we saw earlier. With that being said, now we move towards an interesting document, which is the energy results Excel sheet. First tab here is just a bit of a summary of the system, very similar to a certain degree to the project sheet. However, the interesting information actually starts from the second tab, where we can see here, first of all, information, hourly data of the meteorological data for the whole year. Then we start seeing how much production our plant is actually having for a set number of years. So in this case, for instance, let's say it was 25 years, it will show us all the 8,760 hours of each of these years. And in case there was any, let's say, limitation or curtailment or so on that what we had set, we will notice that very well in this sheet. Also, the same thing will be applied to the nighttime consumption. So we will divide the nighttime consumption from the rest of the production, just so that you have a bit more information and it's easier to look at. And then we will include both of them together in what would be a first year hourly production. And here basically it's going to sum up all the results at different points of the system, like for instance, this array output, inverter output, and then finally the injection to the grid. And you can see here that it's having both the nighttime losses and the production throughout the day. So all the actual final outputs at the point of interconnection. When it comes to the losses, we not only actually calculate them for the first year, but we do calculate them for the rest of the years. So again, in this case, it was 25 years. And we will be able to notice how things are varying here. So for instance, the degradation keeps increasing at the modules, but maybe in case we have losses at the inverter, those could start to decrease, like we see in this case. Well, this one is cabling, but we can see, for instance, maximum power of inverter is decreasing as well. So these are things that you can notice, which will help you kind of decide very well how you want to size your plant, especially when it comes to things like the DC-to-AC ratio, the curtailments, and so on. And almost finally here, we would have the 12 by 24 tables. So this is a bit of a summary, just summing up all those hourly values of all the specific months into different tables at different points. So like the grid, then the plant production, and also the nighttime losses or consumption. And finally, you have a battery energy. In this case, it was not included, as we did not include a battery system within the plant. However, this is information that we do provide. However, careful that we do not necessarily do energy for batteries yet. With that out of the way, I think it's probably better that now we start with the questions, since we don't have a lot of time left. So I'll come back here.
Before we dive into the questions, just I would like to remind everyone that we will be sending an email to all of you, so you can check this report in more detail, as well as our energy methodology. So don't worry, you will receive those, and you can check that in more detail after the webinar. So yeah, let's dive into the questions. I have a few for you here, Hassan. So first, let me start with, do you consider backtracking?
Yeah, so we do actually consider backtracking for the single axis trackers. However, we only consider them for when you're using silicon crystalline modules. So we do have also what are called thin film modules. When you use a thin film modules, we instead would be using true tracking, as that's the usual norm for those modules.
Thank you. Yeah, I think you answered this, but do you calculate energy model for the storage piece?
Yeah, yeah, what I just mentioned, we currently do not do that. However, the good thing is that it is something that we plan on working on in the future. There's no set deadline on exactly when that would be, but it is something that we get requested a lot, and we know that it is the right way to go for as well. So it's definitely something for the future.
Great. How do you calculate the recommended modules per string?
So actually, this is something that perhaps I can pop up a bit the electrical methodology and show you where this exact information can come from. But this brief summary of how this works is that we apply, we take the characteristics of the pan and the on defaults, the characteristics of the modules and inverters, and then we basically use the information like the minimum historical temperature and the maximum historical temperature to calculate those values, which would be the minimum and the maximum values of the range. However, we always take the maximum value of the range as the default or the recommended, let's say, value to show you where how this is exactly calculated. Actually, you can go within the pvDesign. If you come to this question mark, you can go to methodologies, and within methodologies, you will have one called the electrical methodology. And by the way, this is something that we can share with you as well, of course. And within this methodology, you can see some of the formulas on how this is calculated. So for instance, here you can see the exact formulas of how we do these calculations, which includes the parameters that I just mentioned.
Great. I have noticed that the DC-AC ratio is not always the same in PVsyst and in pvDesign. Why is that?
Yeah, actually, this is something that we do get asked a lot. So sometimes it might be the same. Most times, probably it will not be the same. And main reason behind this is a definition of how we calculate DC-to-AC ratios. So in our tool, when we take the AC capacity, we take the Pmax of the inverter. So because of that, we are also using the Pmax of the inverter for calculating the DC-to-AC ratio. Whereas PVsyst, if I'm not mistaken, they always take the Pnom. Thus, the value over there will be slightly different. However, I did mention this during the presentation. There's no need to worry about the DC-to-AC ratio when doing a comparison between both tools, because as long as you set the right number of inverters and the right number of strings, which will set the DC capacity, the electrical system will be covered correctly.
Okay. Is it possible to simulate trackers with different backtracking in the same system?
No, unfortunately not. At the moment, they all follow the same backtracking algorithm. This is a very interesting feedback, actually, that we do receive sometimes. At the moment, it's not something we apply. However, it's definitely something that we might look into in the future, however, probably in the long-term future, not in the near one.
Great. Can you... Hold on, I lost this question. Can you elaborate a little bit more on the uncertainty of the results of the probability scenarios?
Yeah, perhaps I can share again pvDesign. So if I'm not mistaken, I believe you are asking about this parameter specifically, which is the interannual variability affecting the different P scenarios. Basically, for us, it's just the direct value standard deviation that will mainly affect let's say, how dispersed the points on the normal distribution function are, so how close to each other or far away from each other they are. Usually, if I'm not mistaken, PVsyst has different uncertainties, so they have them kind of divided into 2 or 3 uncertainties, and then they kind of sum them up in a way. In our case, it's just one parameter, so you'd have to kind of do the bulk of all of them together and add them together to take them into consideration inside pvDesign. And once you do so, actually, you'll be able to see these scenarios, if I'm not mistaken, have in the report. So this is the energy report that I mentioned when I started with the documentation. You have this table here, which shows you those different values of the P scenarios. So for the energy yield, also it's in the project sheet as well.
Great. Do you consider the albedo effect when using bifacial modules?
Yeah, of course. So it is a parameter. So albedo is something that we are taking into consideration, whether from a database or from a manual input. It is something that you are setting up as a user, and it does to show you the effect of that, or let's say the specific loss related to this, because we do actually report this loss. In this case, yeah, it would be the ground reflection. So this is the loss because of the albedo value, the direct loss because of the albedo value.
Okay, another question. Thank you very much for the webinar. Do you place the panels automatically?
Yeah. So this is something I mentioned, is that we do pvDesign automatically designs the layout for you as long as you set the equipment and so on. However, we by default have everything selected, so you don't really have to change things unless necessary. And it does that automatically, as we can see here. So this is like a preview, a map of how this would look like. Otherwise, if you want a bit more detailed layout, you would see something like this, where you have the different blocks. You have the power stations, or let's call them the MV transformer stations. You have the rows over here, the trenches, and so on. But yeah, all of this, everything related to the layout is really done automatically by the tool.
How about the inverter rating getting derated with temperature or altitude?
Yeah, that's actually a good question. So when it comes to the inverters, usually in the OND files, they have information. So for the temperature, altitude we don't take into consideration at the moment. That's the quick answer. Usually you could contact the manufacturer to check for different altitudes if the inverter should work at a different capacity. However, what you could also do is you can limit the Pmax, so you can lower that value. However, when it comes to the temperature derating, this is something that we do actually apply. So if you come to any inverter and you click on show details, and you can go to the kilovolt amp curves, these curves basically will come from the OND file, and what's going to happen is that pvDesign calculates everything in an hourly resolution, which means that for every hour it knows the temperature, and since it knows the temperature, it's going to check, come back to this curve and say, okay, what's the temperature at this given hour, and depending on that temperature, it will set the required or the corresponding capacity. So the capacity of the inverter will go higher or lower based on the temperature at any given hour throughout the year.
Okay, and since we are finishing here, I'll have one question to wrap it up. One last question. So, can pvDesign calculate hourly energy production?
Yeah, actually, not yet. However, there are some good news here, is that we are already working on that, and we know for sure that we will give you 15-minute intervals. However, we are validating other, let's say, higher resolutions. I'm not going to mention for now because we're still validating them. And this is something that we hopefully plan to have somewhere in Q4. Best case scenario, hopefully it will be there.
Great. So, well, that's up for now. There's a few questions we weren't able to answer, so we'll for sure try to answer those through email. Again, if you're interested in learning more about pvDesign, please feel free to reach out to us and request a demo in our website, ratedpower.com. And yeah, thank you again, everyone. Thank you, Hassan, and thank you all of the attendees for being here with us today. And yeah, have a great rest of the day. Hassan, any last words?
No, just thanks for attending and also for the interesting questions. And hopefully this was useful for you. And we're obviously going to send you all the information that you can also check and ask us any questions about them.
Okay. Bye now.
Perfect. Bye-bye.